Okay, hello everyone. So in the previous video, we discussed about finding vertical asymptotes of rational functions. So in this video, we will find the horizontal asymptotes. Okay, so we'll start with the definition, and then we will learn the methodology on how to determine these horizontal asymptotes, and then we will apply this methodology to three different functions. Okay, so let's start with the definition. So we have here the line y is equal to b is a horizontal asymptote of the graph of a function f if f of x approaches b as x increases or decreases without bound. So let's take a look at this figure right here. So as you can see, the graph approaches y is equal to 2, but it never touches it. So this is a horizontal asymptote. So as you can see, as x approaches positive infinity, it approaches, f of x approaches y is equal to 2, right? So the same thing happens if as x approaches negative infinity. Okay, so y is equal to 2 is a horizontal asymptote here. So how do we locate horizontal asymptotes? Now let's read this. Let f be a rational function given by f of x is equal to, so a n x raised to n up until a0 over b m x raised to m over, I mean up until b0. Okay? So we need to watch out for the degrees here. So the degree of the polynomial in the numerator and the degree of the polynomial in the denominator. So and also we are also going to use um, the leading coefficients. Okay, so there are different cases. For example, in case 1, we have if n is lesser than m. So the degree of the polynomial in the numerator is lesser than the degree of the polynomial in the denominator. The axis, or y is equal to 0, is the horizontal asymptote. So you just need to watch out for the degree first. So then if it happens to be, if the degree of the numerator happens to be lesser than the degree of the denominator, then y is equal to 0 is our horizontal asymptote. Now let's move on to the second one. If n is equal to m, the line y is equal to an over bm. So what is an over bm? So it is just the leading coefficients. So the quotient of the leading coefficients of the numerator and denominator is the horizontal asymptote of the graph of f. Now what happens if n is greater than m? So if that is the case, then the graph of f has no horizontal asymptote. Okay, so let's try to see. And we will try to see the graph of these if this method really pans out. Okay, so what are the degrees of our polynomials here? We have here squared and then squared, right? So therefore, our n is equal to m, right? So that is case number 2. Therefore, the line y is equal to an. What is an? That's 9, right? Then bm, that is 3, is equal to 3. So uh, y is equal to 3 is the the horizontal asymptote. So let's try to see that if that is really the case. So y is equal to 3. So as you can see here, that is really the case. So 3 here is the horizontal asymptote. Okay. So the methodology does work. Okay, so let's start with the next one. So as you can see here, the degree of the numerator is 1. The degree of the denominator is 2. So that means n is lesser than m. So let's go back to our methodology. That is case number 1. So n is lesser than m. Our therefore the asymptote is y is equal to 0. Okay, so let's try to check with the graph again if that is really the case. So as you can see here, y is equal to 0 is really the asymptote. As you can see here, if as x approaches positive infinity, it approaches 0. And as x approaches negative infinity, it approaches 0. So you might find it peculiar that this graph crosses the horizontal asymptote. Now, this is actually the difference between um, another difference between the vertical and the horizontal asymptotes, because the graph can actually cross a horizontal asymptote, whereas in the um, vertical asymptote, the graph will never cross it. Okay, so let's proceed with the next one, the third one. We have here 4x cubed over 2x squared. So the degree is 3 and 2. So therefore, n is greater than m, right? N is greater than m. So let's try to look where that falls. It is case 3. Therefore, the graph has no asymptote. So therefore, we have no asymptote. So is that really the case? So let's try to check. So does this have no asymptote? So as you can see, there is definitely no asymptotes here. There are definitely no asymptotes here. Okay, so that confirms it. Our methodology works. So thank you for watching, and I hope you learned something new. See you in the next video.